All right, so I want to talk again about the padding oracle attack. Now, the first part of this I covered last time, and it worked, where here you encrypt 48 bytes of text. You'll get 48 bytes of plain text will turn into 48 bytes of ciphertext. But if you encrypt 47 bytes of plain text, you will have to add a padding byte to fill this. And the padding system puts a number at the end. If you have only 1 byte of padding, you use a 0, 1. If there's 2 bytes, you use 2 for every byte of padding, and so on. And so that means if you have ciphertext and you decrypt it, if you change this 1 byte here, it scrambles this block, but it only changes this 1 byte here. And that's what I was mentioning with the hash functions. If I can make a change in the input that only changes a small part of the output, that makes a weak spot you can attack with the cryptography. And so what this means is by finding the value here, which is different than the original value, the attacker knows the ciphertext, but they don't know the key or the plain text. But by only knowing the ciphertext, I can modify this value until I stop getting the padding error, and that will mean this must be a 1. Because, all right. And so by trying 256 values there, I can learn this intermediate value there. By doing 256 guesses, I can deduce this 1 byte here. And after I know that, I can then repeat it here and repeat it here, and I can slowly fill in this intermediate value. And it's only going to cost me 256 guesses for each byte. So that's not an immense amount of calculation at all. And so then I don't get the ability to decrypt the message or learn the key from this attack, but I do get the ability to forge 16 bytes of arbitrary text here. So I can trick the system into thinking I did know the key and I encrypted the message when I didn't. So anyway, that's this version of the padding oracle attack, although there are versions that actually get the key and decrypt all the messages. If you just follow the steps I give here, you'll end up finding a few flags and get the first 20 points of this project. But the really fun part, if you got it, if you understand it, is to attack a system without all these instructions. And so I made one remote, and here it is. You download this thing, padorchal2a.pyx, and save it in a folder. And so I should have it here. All right. And there it is. I made a folder here with nothing else in it. And let me make my, all right, there. So I got this padorchal2a.pyx. And I had to make it pyx because my server won't let me download py. The browsers won't. So now you have to change that. All right, you have to change that to pi. So I'll move pador. Get rid of the X. There, now it's pi. I have a Python file in here, and now I can run a Python 3 shell, and now I can import the decryption, and I can decrypt that message. Let's try this. So I import the padorchal2a, which is that function I just downloaded. There's my A, and I decrypt it, and there we go. If I decrypt that message, I get the error no name included. If I give it a completely bogus message, like all just A's, then I decrypt that one, I get padding error. So this is the vulnerable system to attack. This is the point. Now, if you want to understand how this works, you can look in there. It's actually sending API requests up to my server. And on my server, I got Python code running with a key you don't know and you can't find, unless, by the way, you hack my server, get root on it, and steal the key. That would be another way to do it, and you students in the pen testing class might be able to solve this challenge that way. However, for cryptography class, the way to challenge it is by using the padding oracle. So the point is, this error is because what it's expecting to find is a valid input that will decrypt with correct padding, and it has to have a colon followed by your name. And if you do that, it'll put you on the winner's board here. You send in your ciphertext, and first you have to construct ciphertext that can end with colon your name. And it's going to cost you a lot of work to get every byte, so just use like your initials. And I made one, if you look at the winners page, see, last week I got it working, and I put Sam up there twice. So I made 4 bytes. I can put in Sam and then a colon before it. So this is anything ending in colon Sam. And you have to make it end in colon your name, and then you'll be on this board. And that's worth 50 points because it's not easy to do. It's kind of a lot of work. But you do use this attack and chew your way back and get at least a colon and at least a couple letters here to put out some short version of your name. And then you turn in an image. You tell us what name you put on, and we'll make sure you're on here. So you can only get on that board by making something that will decode to a string ending like that. So that's it, and it works. And you can see this shows the principle. I've created a vulnerable system like the ones we talked about before, where you can feed it anything, and it will give you an informative error message that tells you if the padding was okay, you'll get this error. It didn't find colon name. If the padding is not okay, it'll tell you that. And that's going to be enough. So that's what I wanted to show you. It's all working now, and people that are ambitious can try for the 50-point challenge. I usually have a couple students each semester that are willing to do it. All right, that's true. And ACORN has another good point. You can learn how to do it programmatically. There are libraries that automatically do the padding oracle attack. There are a few of them out there. So that's another way to do it. Good? All right, let me see if there are any more questions coming in the, nothing here. All right, I'm going to stop this recording. That's